All right, so in this next example, again, if we take our given information, here WQ is equal to WV, and then TQ is equal to RV. So there's the information provided. I locate where that is in my statements and identify that as given. Okay, so as I move to my next step, I have WQ minus TQ is equal to WV minus RV. So does that fit the structure of segment addition? The difference of two things is equal to the difference of two things? No, segment addition is either the sum of the parts equal the whole or the part equals the whole minus the other part. So the only way to get two things being subtracted from each other equal to another two things is to take the statements themselves and physically subtract them. So if I look earlier, do I have WQ and WV? Yes, I have a statement that those two are equal. So if I remove TQ from one side, I have to remove its equivalent from the other side, RV, and I see that I get my statement 2. So that is two things, or if equals are removed from equals, the remainders are equal. That is subtraction property. Okay, I move to statement 3, WT equals WQ minus TQ. Does that have the structure of segment addition? Yeah, one thing is equal to the difference of two. So if this one thing is a part, WT, here's my part, is equal to the whole WQ minus the other part, TQ, that is segment addition. It fits perfectly. So that's my alternate form of segment addition postulate. Okay, what about WR equals WV minus RV? So again, it fits the same form. So WR is a part. Is that equal to the whole minus the other part? Also yes. So that's another case of segment addition. Again, it'll often be together in the same step, but they could be two separate steps. And then that leads me to my final statement, WT equals WR. So I'm either taking some equation, I'm subtracting values from both sides to be left with this, or I can look to see is it part of substitution. So I'm looking for WT and WR earlier in my proof. So here's WT, and here's WR. Okay. So when I look at those, do I find that they are equal to the exact same thing earlier in my proof? They are not. Okay, so it's not transitive property. So what I have to do is see, can I create WT here? Well, WT is equal to WQ minus TQ. So if I find an equation, like in step 2, WQ minus TQ can be replaced by its equivalent WT. So that's sub. And then when I look at the right side, WV minus RV can be replaced by its equivalent, WR, that's sub. And so this is an example of substitution only to get that final statement.